Aquanaut Research Expedition, a 3-month undersea study of coral reefs, conducted by the National Oceanic and Atmospheric Administration, NOAA. Four different reef environments near Miami were selected for the study.
Air 3 to base. Over Pennycam. Spotted Lulu on the mark. Tom is already within shouting distance. Over. Base to Air 3. Come home. You did your job. Out.
Lulu, a moored catamaran, supports a 3-man mobile habitat, Adelhab 2, living quarters and laboratory in an 8 by 10 foot space. A major mission of FLAIR is to use the living reef as an indicator of environmental health. Nine 2- or 3-member teams of scientists, one team at a time, remain underwater for about 5 days, each with a specific and different scientific objective. Once below, a diver's blood becomes saturated with nitrogen. Air under high pressure from the mothership keeps the water out of the laboratory habitat. Barracuda, queen angelfish, fascinating specimens, particularly to scientists studying the behavior of fish and reef ecology. A complex population of interacting organisms. Sponges pass the same water through their bodies that flows over the polyp colony, forming brain coral. Gorgonian coral align themselves perpendicular to the prevailing current, forming natural current meters. Many specimens are photographed for use later when collating data. Grid lines help the divers maintain their location and aid in their systematic collecting of plants and animals. Women aquanauts, specialists in reef vegetation, take a plant census. Among other things, they note a curious, unexplained disease in reef fish. Findings are discussed with the topside team member. Arrangements are made for the unusual plants collected to be grown in the laboratory for the first time. From the air, the reef is just a pattern in the water. From below, a world awaiting man's exploration. Edelhab moves to an almost barren area, furnished 6 weeks earlier with an artificial reef of 500 bound and weighted tires. Marine biologists count and classify the new tenants and compare their findings with life on a nearby natural reef. At mission's end, the artificial reef has become a natural community. Sport and commercial fishermen may one day take food fish here. On another mission, 3 geologists survey the ocean floor for clues to the past. A device looking like a king-sized vacuum cleaner exposes the secrets of bedrock. Core samples obtained by drilling chronicle evolutionary changes in age and chemistry as far back as the Ice Age. In time, such information may help man predict geological events on land as well as under the sea. There's no way to cook food below. Lulu's surface support team sends down hot and cold food in a pressure cooker. The living reef breathes. To measure its metabolism, a husband and wife team study photosynthesis and reef respiration. The team carries its own specially designed electronic instruments and cameras to the test site. Plexiglass domes isolate coral communities. Small pumps circulate water through the domes and across instrument sensors. Oxygen, light, and temperature are measured continuously. Nearby, electronic circuitry and recorders in watertight containers float above their anchors. Sunlight, the primary energy source for the living reef, is measured by a pyroheliometer. All of these measurements are used to determine the health of the reef environment. Whoops. Flare aquanauts have only 5 minutes to spare after surfacing. Divers stand ready to rush them into the safety of a small decompression chamber on deck. In the chamber, divers are slowly returned to surface pressure, alternately breathing air and pure oxygen. As payment for almost unlimited time on the bottom, the scientists must endure about 20 hours of decompression. Waiting. Both the divers and the support team members agree that this is about the hardest part of a mission. Divers are released only after a doctor has pronounced them physically and medically fit. The expedition was a success. Much was learned, and the portable habitat has been established as a valuable undersea tool. Man needs a great many things from the sea, yet he must conserve its resources and keep it productive for generations. To achieve this will require far better understanding than we now possess. Oceanic understanding is a NOAA goal, and Claire was a beginning. One small step on man's journey under the global sea.